So folks, we are going to look at workshop 9. This part of the presentation is for just workshop number 9 for math 1211, just problems A and B. So the rest of it will be on succeeding recordings. So we're going to go to a whiteboard here, and we're going to look at what we are doing as far as determining whether a given series is absolutely convergent, conditionally convergent, or divergent. And so the best strategy is to test for absolute convergence first. That is, look at the series without any minus signs and determine that. If that's convergent, then it's absolutely convergent and you're finished. Failing convergence for that, you will then try to use the alternating series test to see if it's conditionally convergent. This is the best order to do these things. Don't do the conditional convergence first, because you'll still have to test for absolute convergence after that. Anyway, so here's problem A on this, and it is summation n equals 1 to infinity of -1 to the n, 2 to the n over 3 to the n. And if I strip the minus signs and try to do this problem, we're looking at this series, summation n equals 1 to infinity, and we get 2 over 3 to the nth power. That's a geometric series. We have r, absolute value of r, equal to 2/3. That's less than 1. That implies convergence. And since that series is convergent, therefore the given series is absolutely convergent. Okay. See how straightforward that one is. We tested for absolute convergence first. B part has to do with some factorials. Here it is, n equals 1 to infinity, and we have n factorial squared 2 to the n over 2n factorial. And since I see factorials here, we are going to use the ratio test. Now, there are no minus signs here, so if the ratio test gives us convergence, it'll be absolutely convergence. If it's divergent, it'll be divergent. Anyway, here's the limit. As n goes to infinity of an plus 1 over an. And putting in the expressions, n goes to infinity, we have n factorial, n plus 1 factorial squared 2 to the n plus 1. 2n plus 2 factorial on the bottom. How did I get that? In the 2n factorial, I replaced the n by n plus 1, so it's 2 times bracket n plus 1, which is 2n plus 2. To finish off the reciprocal of an, it's 2n factorial on the top, and n factorial squared on the bottom times 2 to the n. We can drop the absolute value signs, and because everything's positive here anyway, n goes to infinity, and we have n plus 1 squared. Where did that come from? That's n plus 1 over n plus 1 factorial over n factorial. That's just n plus 1. And since they were squared, we see the squared term there. We have times 2 to the n plus 1 over 2 to the n. And on the bottom, we'll take our time here. 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n factorial. And on the top, we have the 2n factorial. And so, okay, see, we have some cancellations here. And we have, as a limit, 2 over 4. Where did that come from? The dominant term on the numerator is an n squared. It's 2n squared. On the bottom, it's 4n squared. 2 over 4 is the limit. That's equal to 1/2. That's less than 1. Therefore, it's absolutely convergent. And we are finished. Okay, I'll end this recording. The succeeding C, D, and E will be on the next one. And so